I'm on a mission to show the world how engrossing human management of sewage can be. And in fact, we followed the flow of domestic wastewater through sewers, lift stations, and primary treatment in previous videos on this channel. If you've watched those videos, or others I've made, you know I like to build scale demonstrations of engineering principles. I did some testing for the next step of wastewater treatment to see if I could make it work, and the results were just bad. Even with the blue dye disguising the disgustingness of this demo, operating a small-scale wastewater treatment plant in my garage is probably the most misguided thing I've ever done for a video. So I got to thinking about other ways humans co-opt microorganisms to convert a less desirable liquid into a better one. And there's one obvious equivalent: making alcoholic drinks. So I've got a couple of gallons of apple cider, a packet of yeast, and a big glass vessel called a carboy. Even if you don't imbibe, whether by law or by choice, I promise you'll enjoy seeing the similarities and differences between cleaning up domestic wastewater and the ancient art form of fermenting beverages. I'm Grady, and this is Practical Engineering. In today's episode, we're talking about secondary wastewater treatment, and a little bit about home brewing too. This video is sponsored by HelloFresh, America's #1 meal kit. More on them later. You probably don't think about cellular biology when you consider civil engineers, even though we're made of cells just like everyone else. We're associated more with steel, concrete, and earthwork, but the engineers who design wastewater treatment plants and the operators who run them have to know a lot about microbes. Here's why. The worst part about sewage isn't the solids. They can be pretty easily removed in settling basins, as I've shown in a previous video. It's not even the pathogens, dangerous organisms that can make us sick. Those can be eliminated using disinfection processes like UV light or chlorine. The worst part about sewage is the nutrients it contains. I'm talking about organic material, nitrogen, phosphorus, and other compounds. You can't just release this stuff into a creek, river, or ocean because the microbes already in the destination water, like bacteria and algae, will respond by increasing their population beyond what the ecosystem would ever see under natural conditions. As they do, they use up all the oxygen dissolved in the water, ruining the habitat and killing fish and other wildlife. Nutrient pollution is one of the most severe and challenging environmental issues worldwide, so one of the most critical jobs wastewater plants do is clean nutrients out of the water before it can be discharged. But because they're dissolved into solution at the molecular scale, nutrients are much harder to separate from sewage than other contaminants. Like domestic wastewater, making a fermented beverage starts with a liquid full of dissolved nutrients that we want to convert into something better. In this case, the nutrients are sugars that we're trying to convert into alcohol. I should point out that making cider is technically not brewing since there's no heat used to extract the sugars. But the fermentation process we're talking about in this video is the same no matter whether you're making beer, wine, or even distilled spirits. It all starts out with some kind of sugary liquid. The way we measure the nutrient concentration in brewing is pretty simple. Dissolved sugars increase the density or specific gravity of the liquid. This glass tool is called a hydrometer, and it floats upright when suspended in a liquid. Just like a ship sits a little higher in seawater than it does in freshwater, a hydrometer floats to a different height depending on the density of the fluid. The more sugar, the higher the hydrometer rises. On the other hand, characterizing the strength of sewage is equally as important, but a little more complicated. For one, not all nutrients change the density of a fluid equally. But more importantly, there are a lot more of them than just sugar, and they can all exist at different strengths. So rather than try and separate all the complexity, we usually just measure what matters most. How much dissolved oxygen would organisms steal from the water to break down the nutrients within a sewage sample? The technical term for this is biochemical oxygen demand, or BOD. In general terms, treatment plant operators measure the amount of oxygen dissolved in a sewage sample before setting it aside for a 5-day period. During that time, critters in the sample will eat up some of the nutrients, robbing the dissolved oxygen as they do. The difference in oxygen before and after the 5 days is the BOD. Once you know your initial concentration of nutrients, whether sugars or other stuff, you can work on a way to get them out of there. In both sewage and brewage, we expropriate tiny biological buddies for this purpose. In other words, we use them to our advantage. Wastewater treatment plants rely primarily on bacteria, with some protozoa as well. There are a myriad of secondary treatment processes used around the world, but one is more common than all the rest, and it has the best name too: activated sludge. After the primary treatment of removing solids from the flow, wastewater passes into large basins where enormous colonies of microorganisms are allowed to thrive. At the bottom of the basins are diffusers that bubble prodigious quantities of air up through the sewage, dissolving as much oxygen as possible into the liquid and maximizing the microorganisms' capacity to consume organic material. This combination of wastewater and biological mass is known as mixed liquor, but that's just a coincidence in this case. Either way, you definitely don't want to be drinking too much of it. Fermentation of an alcoholic beverage, the process where sugars are converted to ethanol, works a little bit differently. First, the microorganisms doing the work in fermentation are yeast. These are single-celled organisms from the fungus kingdom, in some ways similar, but in many ways quite unlike the bacteria and protozoa in a wastewater treatment plant. In fact, brewers work pretty hard to keep equipment clean and sanitized so that bacteria can't colonize the brew. The foam you see in the carboy before I filled it with apple juice is a no-rinse sanitizer meant to kill unwanted microorganisms before pitching the wanted ones in. The yeast themselves will even take advantage of the antimicrobial effects of the very ethanol they produce. Another difference between the processes is air. Except at the very beginning, when the yeast are first expanding their population, fermentation is an anaerobic process. That means it happens in the absence of oxygen. A wastewater treatment plant adds air to speed up the process. However, yeast exposed to oxygen stop producing alcohol, so the vessel is usually sealed to minimize the chances of that. The bubbles you see are carbon dioxide that the yeast create in addition to the ethanol. An airlock device lets the carbon dioxide vent so it can't build up pressure without letting airborne contaminants inside. As the sugars are converted and CO2 gas leaves the vessel, the density of the liquid drops, and that change can be measured using a hydrometer. My cider started at a specific gravity of 1.06 and fermented down to 1.00, meaning it has an alcohol content of around 8% by volume. However, just like the outflow from an activated sludge basin, it's not quite ready to drink. Once the microorganisms have done their job and the liquid is nearly free of nutrients or sugars, you need to get them out. In both brewing and wastewater treatment, that usually happens through settling. I have a separate video that goes into more detail about this process, but the basics are pretty simple. Most solid particles, including microorganisms, are denser than water and thus will sink. But they sink slowly, so you have to keep the liquid still for this type of separation to work well. Wastewater treatment plants use settling tanks called clarifiers that send the mixed liquor slowly from the center outward so that it drops the sludge of microorganisms to the bottom as it does, leaving clear effluent to pass over a weir around the perimeter to leave the tank. Similarly, you could see a nice layer of mostly dead yeast on the bottom of my fermentation vessel, typically called the lees or trub. Homebrewers use a process called racking, which is just siphoning the liquid from the fermentation vessel while leaving the solids behind. In both cases, these microorganisms are not all dead. That's where the activated and activated sludge comes from. A rotating arm in the clarifier pushes the sludge to a center hopper. From there, it's collected and returned to the aeration chamber to seed the next colony that will treat new wastewater entering the tanks. Of course, not all that sludge is needed, so the rest must be discarded, creating a whole separate waste disposal challenge. But that's a topic for another video. Similarly, the yeast at the bottom of my fermenter are not all dead and can be reused in another batch. Commercial breweries and home brewers alike often use yeast over and over again. However, they mutate pretty quickly because of their short lifetime, so the flavor can drift over time. At this point, both the wastewater and my hard cider are quote-unquote nutrient-free. They're generally ready to be safely released into a nearby watercourse and my tummy, respectively. However, there are some final tasks that may be wanted or needed in both cases. As you can see, my hard cider doesn't look quite like what you would buy in a can or bottle at the grocery store. I'm not going to carbonate it in this video, but that is an extra step that many cider makers and most beer brewers take. I will add an enzyme that helps clear up the haze from the unfiltered apple juice. It doesn't make it taste any different, but it does look a lot nicer. Like the finishing steps of homebrewing, many wastewater plants use tertiary treatment processes to target other pollutants the bugs couldn't get. Depending on where the effluent's going, standards might require more purification than primary and secondary treatment can achieve on their own. In fact, wastewater treatment plants have been experiencing a relatively dramatic shift over the past few decades as they treat sewage less like a waste product and more like an asset. After all, raw sewage is 99.9% water, and water is a valuable resource to cities. In places with water scarcity, it can be cost-effective to treat municipal wastewater beyond what would typically be required so that it can be reused instead of discarded. A few places across the world have potable reuse, also known as toilet to tap, where sewage is cleaned to drinking water quality standards and reintroduced to the distribution system. Wichita Falls, Texas, and the International Space Station are notable examples. However, most recycled water isn't meant for human consumption. Plenty of uses don't require potable water, including industrial processes and the irrigation of golf courses, athletic fields, and parks. Many wastewater treatment plants are now considered water reclamation plants because instead of discharging effluent to a stream or river, they pump it to customers that can use it, hopefully reducing demands on the potable water supply as a result. In many countries, purple pipes are used to distinguish non-potable water distribution systems, helping to prevent cross-connections. And sometimes you'll see signs like this one to prevent people from getting sick. On the other hand, practical engineering's effervescent effluent, when enjoyed responsibly, is perfectly safe to drink. Cheers.
But you don't want a beverage without a home-cooked meal, so it's time for everyone's favorite segment of me trying to cook while my wife tries to capture that on video. We're thankful for HelloFresh, the sponsor of this video, for converting cooking from a chore into one of our favorite ways to spend family time together. We're even trying out a new kitchen stool for our little helper.
I wonder if you're gonna regret leaving that pan right there.
Leisure time is a little less leisurely with a baby, something that's soon to be twice as true for us, so we love that HelloFresh meals come together quickly. They even have options for 20-minute meals and low prep because anyone with a toddler knows how hard it is to keep them busy. My wife was not so approving of all of my methods.
A cup of dirty ice.
They also have options for family-friendly meals, pescatarian, vegetarian, and more, so it's a really nice way to jumpstart a change in your diet or just try something new.
Can you pick the onions out of mine?
The pre-portioned ingredients means there's less prep and less food waste, and the packaging is already recycled content, and most of it's recyclable as well.
Did you know that when I was little I could do this with like my eyes closed? There, that looks fair.
Go try it yourself at HelloFresh.com. If you use my code PRACTICAL16, you'll get up to 16 free meals plus 3 surprise gifts. That's HelloFresh.com and use my code PRACTICAL16. Thanks HelloFresh and thank you for watching. Let me know what you think.